manufacturing, technology, hot topics, and a little bit of tomfoolery. This is the MTD Podcast.
MTD Podcast, Series 2, Episode 2, and in the background, you can hear the door opening because someone's just come in as we're recording, but we're consummate professionals, so we're going to have a fight with them later. I'm joined by the big guns, the small guns, and the medium guns. We got Giovanni Albanese.
Elko, how you doing, mate?
I'm all right. Mr. Joe Reynolds.
Guten Tag.
Yep, he's all gone German because he's been at EMO in Milan. And Mr. PJ.
Sprechen die Deutsch?
9. No, it's 4 of us, actually. So, we had some highlights. 27 halls of engineering porn, I think someone called it. I'm not sure.
Excellence.
Yeah. Excellence.
Exuberance.
Oh, excellent stuff.
Solutions.
Got to say, I listened to your podcast last week or the other day. I thought it was really good.
Thank you very much.
I learned a lot.
Okay, right.
What did you learn?
Well, I learned certainly about what Colin was talking about the Citizen machine. I thought that was interesting.
Well, Citizen Miano, I was corrected.
Miano
Yeah,
machine, because also I know taught that with the Swiss Deco that I went to Switzerland to look at, which was also at EMO this year. It's a similar concept of machine with that B-axis.
B-axis on the turret.
B-axis on the turret. Yep. But it's taken machining into a whole new level. And in fact, they had presentations there throughout the week. In fact, every 2 hours, and they were drawing so many crowds. It was incredible. You were there, Gio, as well. We saw it.
Doesn't this kind of relate to what Joe referred to last week as well? Artificial intelligence. Without that CAD/CAM software now, how would you be able to run these complicated machines? It's simplifying the way these machines can operate. You imagine programming these 9-axis, 10-axis, simultaneous machines. This new CAD/CAM...
It's chicken and egg, isn't it? What comes first? You have to have the software there to be able to program them, or do you develop the hardware around what software's available?
Bit of both, isn't it? Bit of both.
As long as there's no turkeys involved, we'll be fine.
I've got a question, though. What I was really interested in is, you were talking about highlights. One of mine was the plane journey back, the last 20 minutes.
Oh, God.
I can't remember some of it, but I heard that there was an incident as we left the plane. Someone tried to pull my trousers down, didn't they, Joe?
Ooh.
The video is available. It's a subscriction service if you want to see the video, and you must have deep pockets. But yeah,
now you've got to pay not to see it. It's going to go out stream live.
Yeah, if you don't subscribe to our channel, you will get sent it. Yeah.
Well, I wasn't on that plane journey. Thank God is all I can say, because it sounded like absolute chaos. Paul's actually didn't join us for the first thing because he was stuck in quarantine. So anyway, enough of Paul chatting on about his highlight. Joe, what another highlight from EMO? 27 halls of engineering excellence, if I can say that.
I'm going to go with the new GL lathes from Romy Machine Tools. Paul joined me on the stand. Typically, when you see a new machine tool enter the market, it just may be a change of a theme. They might have changed the control, but every item on this machine is different. Everything from the CNC control down to the casting, down to the guides, everything is new.
Visually, it looks beautiful as well.
It's heavier machine too.
Yeah. I think it's 45% heavier than the previous model. So it's now got milling, Y-axis, sub spindle. In truth, the old range, I think the Series 4, this one. So the Series 3, version 3.
Good maths, Joe. Yeah, well done.
It's a great machine, sold many across the world, but in truth, the range was flawed. It didn't have sub spindle and Y-axis, and fundamentally you need that in the modern market.
I thought they did that. That's really interesting that you say that, because I'm sure when we've been to Rome and Rugby, never had the sub-spindle lathe. It's always been driven tools and a Y-axis. Did they have Y-axis?
No, I don't think so. Milling functionality. But now it's full. It's everything you need in the marketplace.
Like
and they've added more models to the range as well. I think there's five different sizes. So yeah.
Impressive stuff.
And it drew a big crowd, as you'd imagine.
Gio, next, what about yourself?
I think if we're going on to the theme, I don't think we really brought machine tools into play yet, but if we're going to stick to machine tools, I think my highlight was the Porter Solutions.
Portaloo. Right, sorry.
It was a rough night.
That was after the plane journey, wasn't it?
Yeah. Well, if you can imagine a machine in a very small footprint.
Hold on. Yep, got it. I just imagined that, yeah.
With 3 spindles.
Okay, hold on.
Horizontal spindles.
Yep, got it.
Yep. 3 pallets.
Hold on. It's going to be a long show. Keep going, Gio. Come on.
Well, anyway, you need to watch Paul's video. It's trending quite well on MTD CNC, and it will explain that machine quite well. I mean, this is revolutionary. I mean, effectively, you've got 3 horizontal machines in one with the spindles working simultaneously. It's something that's totally unique that I've not seen in the UK market as of yet.
I've not, and I'm surprised when I saw it why it hasn't been thought of by, let's say, a DMG Mori or a massive manufacturer, because I can see the competitive advantage.
Massive.
Who was it again? Sorry,
Porter Solutions.
Porter Solutions. Okay, not Port Toulouse.
3 high-speed horizontals, all fed with their own tool changes as well.
The tool changes are above the spindle as well, so the tool change is literally instant. The design is a phenomenal design.
If you can imagine a tool change on a machine, hang on, you got it?
No, I think, joking aside, me trying to imagine it's going to be too long, but definitely you've done a video on it. What channel would that be on?
So that would be on the MTD CNC YouTube channel.
Okay, good. Okay. Now my turn, because you have had, I think you lot have had enough. I'm going to go work holding, because we have seen before via NCMT the blue photon. Absolutely. Well, work holding solution, glue, you curing it with UV light. Really, really strong. I think it's £200 per light.
Quite cheap.
Just holding it. Different complex shapes. But with additive manufacturing now, you can make that work holding solution for such complex shapes. It's absolutely amazing.
What do you mean by that, Colin? Explain yourself anymore.
You're going to have to imagine it.
But you what you're saying is that when you're holding that intricate part, say if it was like a 6-legged part, the actual 3D printing comes into play because you can put the glue exactly where you need it.
That 3D print, you'll 3D print the fixturing and then put the lights into that fixturing. Then you'll glue it. And then you could take that 3D printing away.
I guess you imagine a turbine blade, a regular shape. You can't be holding that, do you? The surface it's going to be glued to needs to be.
He must have seen the video because there is a video on the MTD CNC Global channel, which you did, Colin. And I've got to say, it was really good. I watched it.
I definitely didn't see that one.
Within 60 seconds, you can see where it can be used. And it's
You're essentially gluing something to something else, aren't you? So it needs to be. No point doing it to a flat surface.
But it isn't going to be for everyone. I mean, it's a good innovation.
Complex parts.
Complex parts.
Application specific.
Well, easy for you to say, I tell you.
You just glued my lips together.
They had a spine implant, a sphere, turbine blades, all sorts of things. Absolutely amazing. Anyway, I've had enough of myself, although I watched a video because it was very good because I was in it, as you would expect.
I've got a left field one.
Uh-oh.
It's, you go around all the stands, an abundance of like quality components are being machined at the show, isn't it? Like one stand had that giant bull that's been done on a 5-axis machine and various others. What was
Bull or ball? It's your accent, mate.
Bull.
As in. Okay.
Hey, I got to be honest. I come from West Midlands and they sound slightly different, but yeah, I think we're on the same wavelength.
They don't win Collins on the back of it.
I've had worse, mate. Don't worry. Anyway, come on, keep going.
Yeah. So, what was your favourite component you saw at the show?
Oh, that is a tricky one. I mean, I've
got
Go on, Colin.
I saw a crankshaft for a marine engine. It should have been, people will have guessed it already because it's going out as a cycle time challenge. It took, that's a drum roll, 7 days to manufacture.
Right.
That sounds like Paul on your old machines, Paul.
Well, I did used to machine crankszafts.
Yeah, but this is flipping humongous, mate. I
Yeah,
think
cycle time was
technically
20 minutes. It took 6 days to load the part, probably.
We used to scrap them.
Yeah. But it was about 4 meters long. I didn't actually measure it myself, but huge.
Paul, have you got a better one? That sounds quite boring.
No, I mean, no, because I've come into that. I was very focused on the machines, and one of the things that the theme I found from the show was all about the automation. And if you went onto the Fanuc stand, and I know you did as well, they had, and in fact, this robot that was on the stand is going to be at their event, their automation event on the 29th, 30th and 31st of October. It's got the heaviest payload of any robot around the world. And it was picking up, I've seen it actually pick up a car before. I know there it was just
your
picking up
car because it's so badly parked as usual.
I know it was just picking up an engine block there, but
two engine blocks.
Two engine blocks.
You can pick up a car, but it couldn't pick Paul up.
But it was fantastic to see. You can all stop laughing now because that wasn't a funny joke. But what I also thought about the Fanuc stand on the automation is they had what they classed as like a mini robot. I don't know whether you saw that basically went from machine to machine, and it would avoid anything that was in between it, and it'd go to a collaborative, or it basically had a collaborative robot on it. It'd move to a machine, put a part in, take a part out, and it would just like a robot does, almost like not walk away, but roll away, and then it go to another machine and do the same again. And the
robot on wheels.
That
made it quick, simpler, didn't it?
Yeah.
Joe, thanks.
But how effective could that be in a machine shop when you're looking? Lots of people think of one robot, one machine. Well, you don't need one robot.
Well, Joe, I visited Toyota in 1996 for the first time, and it wasn't new then. It's incredible how long it's taken to get mass adoption into the marketplace for that technology. But that, it's there's no reason not to use that.
Well, Halter do not a similar thing, but you can move their robot from one machine around the machine shop to 4 different machines, and they're the big ones, not the like. When you're saying collaborative sort of cobots, you're thinking the small one sort of maybe a payload of 10 kilos. But the halter ones, they'll do up to 70 kilos.
Yeah, I think
now.
Paul's on about it literally drives itself to a machine.
Absolutely. This is all digitalisation, isn't it?
And
though?
it's fully health and safety. You know, you could walk past it and it wouldn't run you over.
Well, it just beeps and you have to get out of the way.
Yeah, yeah.
They make you a
It
drink,
might run you
probably.
over if you programmed it to. But it was really great to see their stand. All of their machines were fed by automation, even their EDM machines. So they'd got robots on their EDM machines, and you don't associate an EDM machine with something that needs to be, parts changing all the time, because they tend to run overnight, don't they? But they're still demonstrating where those
Paul,
that accountability.
I'm going to stop you there because I think it's Gio's turn.
Favourite part, Gio? Favourite part? Component?
Well, I don't really. I've seen many parts. I think one of the parts that I've seen was an actual U-drill being manufactured from a solid block.
Oh,
But
that's
I
good,
mean, I'm going to move on to another machine. A machine tool manufacturer, Grupo Parpus. Now, not the actual machine tool, but they again, it was some new innovation that they were showcasing on the machine. Now, this particular machine tool was a large gantry-style machine tool with a very large working envelope. And you can imagine the kind of size parts that would fit in there, big mould tools, for example.
Do you want me to imagine it?
No, definitely not.
That's
effectively,
big, yeah, got it.
they've got this new technology that runs inside the machine tool that will scan the footprint of the machine. If you can imagine you looking above from a plan view, if you're looking above a city, this drone can calculate in a 3D perspective everything within the envelope of that machine. So it's effectively scanning everything in the envelope. So when it's machining, it know exactly where everything is.
Is the idea to
makes
scan
any
the
sense.
component and the billet, or is literally the machine bed so you know how the bed is?
Both. It can do
Anti-collision.
both.
Is it so that you can factor in the anti-collision factor when you are machining? It's not going to hit a high point, or
It's 3D. I would imagine both aspects. It's beneficial because imagine setting the datums on something so large, or if you've got a new mold tool that comes in, and I'm just speculating here. You don't know exactly where each feature is. You'd have to check it first before you put it into the machine tool to machine it.
What accuracy would it go to?
I'm not sure.
Okay. Well, that's ruined that one then, hasn't it? Yeah, sorry, mate.
that was on Swarf and Chips as well, wasn't
Yes.
it?
Yeah.
Yeah, no, it was how many people will invest in that technology remains to be seen, but it's a good idea.
You imagine? Well, I was told that it would usually take a day to scan a component in that kind of area, that size.
And how quick was that doing
A
it?
couple of minutes.
3 days.
Right, go on. Now,
Right, can I talk about my components?
No, it's my go.
You
go on. You
components.
talk about your component.
So there were three main ones, all driven by Autodesk software, funny enough. All this generative design you may or may not have come across. There was the project they did with Volkswagen, where they essentially you take the wheel, an alloy wheel, and you say, I need 5 holes here because it's got to fit to the car. It's got to be round. I need
That's
a hole
always a good
here.
start on a wheel, Joe.
Exactly. I need a hole here for a valve, and the software does the rest, and it chucks up. It looks irregular. It doesn't look correct, but it basically the design is optimized. Secondly to that was they had like I can't think of the name, but essentially something you'd travel to Mars or the moon in.
Spaceship, I would suggest. But
Yeah, but it's like the landing part of a rocket, if you like, and that was all generative design, exactly the same. And the third, again, generative design.
Just to explain that again, generative design.
So essentially, a few things like a bridge. A bridge is nice triangles, everything's as it should be. That's what we think. But if you use machine learning and AI, they would tell you you're wrong. The algorithm.
So to get the maximum strength in the part,
and it looks. Have a look online. It just looks wrong. It doesn't look like it should be made like that, but it is correct.
So how does it work? Sorry.
It uses the power of the cloud and machine intelligence and AI and things like that to
So it's
to
taking
generate
data
it.
back from previous operations or
Yeah,
previous
yeah,
applications.
and you do have to, and it's really intelligent. You can say it's got to take a load of 4 ton. It's going to have a stress here, a stress there, and it calculates the rest for you.
But what it does, it'll start off with one option and then it'll go to another option and say, well, actually, this one's better. And it just, because of the processor, computer processing speed, it could look at so many different options and it ultimately come up with the best option.
And you can say I want it designed for additive manufacturing, 2 axes, 5 axis machining,
weight reduction.
Exactly, I need it lighter.
Are you
And
looking at Paul or
the
Joe?
cloud changes it all.
Now, this is really interesting. I know Lindsay's going to join us in a minute. She was here
She's not.
to witness this. And Gio, when we were on the Esprit stand, they were talking about artificial intelligence, weren't they? Yeah. And I can't remember the gentleman's name that runs it. Was it Dan?
Yes, it was.
Dan, the owner of the company. He was talking about how artificial intelligence is evolving so quickly. And there was Google and amongst one of its other digital companies came together to actually, they had an artificial algorithm that they wanted to get clever on its own, essentially. And it got too clever. And what happened is they had to shut it down because it started doing things that it shouldn't be doing.
Have you not seen the film War Games? That's where they play tic-tac-toe.
That will happen.
It's in reality. The robots are the artificial intelligence. They're getting cleverer and cleverer on their own doing, as you're suggesting.
I can honestly see 20 years' time, school will be optional. Because you think your smartphone, everything that's available on your smartphone will be on a chip in your brain, should you choose. And that will happen.
That's the kind of...
that will happen.
That's the kind of...
Anyway, come on, we're moving on. I can hear some rustling in the corner. That's because Joe is leaving. Oh, bye, Joe. But...
Come on, Lindsay.
Yeah, there you go. Well, there's a... No. In you come, Lindsay.
You know, just adding on to hello, everybody.
Can you use your microphone, please?
Hello, sorry. Yes.
So, welcome to the podcast. It is Lindsay Vickers, otherwise known as Lindsay Vickers. No, that's all we got.
No, yeah, that's all you got. Just to add, just really briefly, just jumping on what you just said there, Paul.
No.
It's quite interesting.
You can go.
Okay, thank you. It was quite interesting because he said the two computers were talking to one another, and within 3 minutes or within something like 30 seconds, they were talking to one another in English. Then they went through different languages, and then they created their own language within I don't know what the timescale was, but they became that intelligent. The two robots were talking to each other in a language that none of us.
Were they taking the P out of Jonesy in a different language so he couldn't tell? Was that a bit harsh?
Yeah, that's why I shut them down.
Right. Anyway, highlight for you, Lindsay.
Well, to be fair, we did a
travelling with us.
Oh, travelling with you. Oh my goodness, that flight home. Can I tell
that? That's one of my highlights.
I want to put a disclaimer in. I was not on this flight, all right?
Bye.
Yeah, Joe's making it now because he...
I've got to tell you something, that on their flight home, that we all know that Gio doesn't like flying. And so Gio takes diazepam to calm down. And
but not the whole packet.
Yeah. Well, he convinced Paul, not only had Paul just had a couple, just to, wind down as you naturally would, to have diazepam as well.
Oh, really? But you're not supposed to wash it down with wine, are you?
She's winding you up.
Anyway. He didn't do that.
Okay, moving on swiftly. So that was probably your low light. What was the highlight of the show for you?
You know what? We did a Swarf and Chips takeover show, and it was on the Renishaw stand. And
did it measure up?
It did. Oh, gosh, you've got more intelligence since I saw you.
I've been talking to a computer in a different language.
Well, we were on the stand, and to be fair, metrology and everything kind of goes over my head a little bit, but I got to understand what it was all about.
A light bulb moment for you.
It was a light bulb moment for me.
That's good.
And we spoke about metrology. We also spoke about how machine tools are pulling data and then people can improve processes, et cetera, et cetera. Well, now that's what what Renishaw are doing. They're producing data that can go back to the user to produce trends and of measurement trends and temperature. And there's so much now data that we can use to make processes better.
And one of the points that came out that I learned about at that show was the fact that the measurements, the tolerances are getting far tighter, aren't they, on components? That's why the measurement has got to get that much better.
Yep.
For example, the electrification of vehicles, the engines are, machined and made to far tighter tolerances.
What sort of tolerances?
I couldn't tell you, but the technology has to be even better now to measure them. Because
the components become far more complex as well as the tolerances, not just the tolerances, but the complexity of the components as well with the different machining technologies that are available. So checking them is a lot more difficult than it was in the past.
Why do electric motors, you probably don't know the answer, but I'm going to ask it anyway. Why do electric motors need to be machined much more high tolerances?
I don't know, Colin. It'd be interesting to ask the audience, if people do know, to comment and let us know. I mean, but during that conversation I had there, or maybe Gio does.
Well, I think that the weight is a big factor now with the electrification because we've got to reduce the weight of all the components within the vehicle because to allow for weight of the battery. But in
Paul's weight.
No.
John's weight. We can say that now. He's gone.
There's no battery big enough.
If you're reducing the weight of a component, then you've got to make them stronger. The design of the housing, if you like, for the battery needs to be stronger. So the design of it is more complex. So that instead of having
this is a long way of saying you're not sure either.
So I am sure there's more componentry involved in.
Yeah, absolutely. Yeah, because if you were designing something square, the stress points it'd be greater. So everything's got to be rounded now. So it got more strength. But it's all clever design.
There's also probably another reason for it that engines. They're having to last longer these days. So in order to last longer, they need to...
That's a very interesting question. How long did your new car engine last?
Well, not that long. So obviously that wasn't
Weeks,
measured.
months?
You're not put any of the blue.
They didn't use
add blue
Renishaw
in.
to No, it was a different product. The turbo blew up.
Oh,
6 months, I think you'd had
Can I
it.
just add to this? 'Cause I haven't finished.
Oh, God. Go on.
Can I?
Yep.
Also, we were talking about like the CMM machines as well, because that's all measurement within the machine, but also after the process as well. That was quite interesting. And they're not just using the probes, they're using like pictures and scanning now. But then we also discussed with them is additive manufacturing, and they were talking about metal additive manufacturing. And it's really, really interesting what they were doing. They had a bike, and they showed us the frame of the bike that they'd made, and it was fantastic to see, wasn't it?
Yeah, but what was the strength integrity on that, though? Would be interesting.
Okay. Oh, it's all gone quiet. What's going on?
Oh, sorry.
Reynolds just poked his
Yeah, I need to move.
So Joe left about an hour ago and he just realised he's been blocked in.
Yeah.
Yeah.
You
Keep
can
going.
move your car quickly.
Yeah.
And
Go on.
there's just a couple
Go
of
on.
points I wanted
Quickly.
to mention.
Thank you for popping in, Lindsay. It's been an absolute delight for you.
The other thing, and I know Gio was with me on these, but the spinner micro turn is a machine, a very small footprint machine. There's a bit of a theme coming here from me. I'm going to rattle through it. But the spinner micro turn, a very small, nimble sort of mill turn machine that's got a I think it's an HSK. I can't remember the HSK back end on the top of it, but you might remember, Gio.
No, I think it was the smallest HSK.
It's the smallest HSK you can get.
Yeah.
Mill turn machine. It fits in a very small footprint, turret at the bottom, very quick, very agile. From Whitehouse Machine Tools in the UK, but if you are manufacturing medical components, complex parts for the automotive industry, perfect solution. And to see it move, it was incredible. Like the Muratech machines that we saw, gantries all over the place, picking parts, placing parts, washing them, orientating them.
It's like being drawn in just watching the poetry in motion.
The speed of the Muratech machines move. They had facing spindles. They were doing Op 1 and turning over Op 2. Then the turrets, and then you had a 3-turret double Y-axis machine, and the parts coming off it were just something else.
Gio, next, come on.
I think staying on the theme of machine tools, Toshiba as well, Paul. Very small footprint machine tool, but up to 60,000 RPM, making components to nanometers in tolerances. Nanometers. So your first question would be, how do you make them so accurate in a temperature controlled environment? So the rigidity of the machine needs to be the build of the machine needs to be absolutely top class, but also they cool the machine with like a cooling system underneath the machine. I'm not exactly sure how it works.
Can I just clarify on nanometers? Is that fractions of a micron?
Yes. I mean, how do you even measure that? Never mind produce a
small
component.
But why do you need to make a part to that sort of accuracy? This is my question.
I'm not an expert on that, but I would guess that I think that it's for moulds, isn't it, Paul? So two mating parts. So if they had to be like a mirror finish and compressed to make the actual whatever part that they're making, it needs to be absolutely perfect with no flaws whatsoever. That's the only analogy I can imagine that you'd need anything so accurate for. But I'm just guesstimating. If there's anyone listening to this podcast, please comment and let us know.
And Lindsay, you went into the DMG Mori Hall, didn't you? And I mean, wow, wasn't that?
I mean, it's huge.
Well, there's 27 halls there, but they've got their own hall. Let's just clarify.
You know what I could not believe, and I said this to you, I got off the flight and there's all branding of DMG Mori. I went through to the hotel, on the doors at the airport, there's branding. At the train station, there's branding. It's almost like EMO takes over, and all of this branding and machine tools, it's fantastic. I've never ever been to a show like it.
Even though people said that this show, when you walked around it, it did feel that it wasn't, that the aisles weren't bustling. However, it's so big and so vast.
Yeah,
how would you wouldn't do that? But there is
that.
every possible solution. I'm sure we can.
Absolutely. I think we're going to round it up now. So thank you for joining us. I want one very final 20 seconds each. Gio,
I think automation, digitalisation. I think it showed. The show showed how it was embracing the two and incorporating the two with all the solutions that most exhibitors were exhibiting.
That was 35 seconds. But anyway, Lindsay.
Well, I'll shorten it. Okay. I'm just going to echo what Gio said. Automation. We went onto the top automate only stands as well, talking about the bar feeds and the changes, but the improvements within those as well. Getting data and those improving as well. So it's not just the machine tools,
not just the hardware.
It's everything around them now.
That was 35 seconds as well, so you didn't shorten it. Paul, you've got 10 seconds.
I think the show showed. I think there was so many highlights. The Nakamura machines, all about, which Lindsay saw as well. The new MX100 small footprints was a big feature there. Small footprints, maximising what you can get out of a small footprint, and adding automation automation to it, because remember, people say that, automation loses jobs. It doesn't. For every job lost in automation, 3 are gained. And that's a big message that I wanted to take from the show.
Okay, that was 35 seconds as well, so I've got no time, but I'm going to use it anyway. So automation, but it's not just about robots. You're thinking automation. You're also thinking it's like your bar feeders, but also pallet loaders and things like that. And there's some amazing pallet loaders. I saw a great one at Wasserman. They had 4 stations. So
35 seconds already.
Yeah, I know.
Sorry.
God, so we're going to finish it there. So that was MTD Podcast Series 2, Episode 2. Gio, thank you for joining me. Paul, thanks for joining me. Lindsay, you can go now. And that's it for this week. We will look forward to you hearing us soon.